So now we're ready for question number 6. It tells us that and I went through this fairly closely in class, so I'm not going to go real fast, or real slow, but we're going to write the filling order for an element that has the following quantum numbers. So the first thing you look at is n equals 3. So if n equals 3, you know your last electron's in the third energy level, and then L equals 2, that means 3d. So third energy level, d sublevel. M equals 0, that's one of the orbitals in the d sublevel. We'll look at that in just a second. And then the electron will be spinning clockwise. And by convention, we said in class we're going to call that one the first electron in. All right, so here we go. We're going to put electrons in. You have 1s, and you have 2s, then 2p, 3s, 3p, 4s, and 3d. That's the filling order. You can get that by following your periodic table, or you can get it by following the diagonal rule. Now, if I put the actual superscripts in for the electrons, oops, there'd be a 6 in a p. So 2 in the s's, 6 in the p's. Until you get to the last sublevel, then you only put in what you have left. Oh, and we don't know that yet, so I guess I won't tell you that. But it's going to be 3. I'll let the cat out of the bag, so to speak. Okay, all the s orbitals, sublevels, I mean, have 1 orbital. And all the p sublevels have 3 orbitals. And the d, of course, has 5. Now, if I were to number them, if I put the quantum numbers in, all of the s quantum numbers are going to be 0. So 0 for that, 0 for that. The p quantum numbers are 1 for a p sublevel, if L equals 1. P, it's called a p sublevel. If L equals 0, we call it an s sublevel. So L equals 1 is a p sublevel. I put the wrong number there. So let's get rid of that. Oops, not that though. And so that number here, we'll just erase that. That's a little boo-boo. So that number should be a 1. But it's a persistent little boo-boo. All right, now let's see if it'll go away. All right, now back to here. This should be a 1. Yay. All right, and then the s is a 0. And the d, for a d sublevel, the L value is 2. So I'll put a 2 there. Now I'm going to number the orbitals. So if L equals 0, then M has to equal 0. L equals 0, M equals 0. L equals 1, M equals -1, 0, or 1. L equals 0, M equals 0. L equals 1, so you have -1. Gosh. You have -1, 0, and 1. L equals 0, M equals 0, L equals 2, M equals -2, -1, 0, 1, and 2. So now I think I have my M equals 0 value, so I'm going to put electrons in here. We said that spin is +1/2, so will that be the first end or the second end? No, it's the first one that goes in the orbital. So here we go. Here are the electrons. First 2 are going to go in there. Whoop. Man. Something's out of whack with my pencil. Here we go. 1, whoops. 1, 2, 3, 4, and then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I don't really have a number that I'm going to, except that I'm going to stop when I get to the M equals 0 in the L equals 2 sublevel of the third energy level. And that is right here. So I'm going to go a single one, and a single one, and a single one. And that's where I have to stop. So that's the first electron in, because it's +1/2, in the third energy level, D sublevel, M equals 0 value. So now you can see that there are 23 electrons. So if I had asked you what the element was, you would say it was vanadium. That's it. I didn't ask you the quantum number, but if I did, that's what it would have been. So now we want to know the 4 quantum numbers for the highest energy electron in iron. So iron has 26 electrons. So you have 1s, 2s, 2p. I'm going to go ahead and put the superscripts up here for the electron configuration: 2p6, 3s2, 3p6, 4s2, 3d10. Now I'm going to put the orbitals in. Oh wait, I went too far. Can't be 10. I'm sure you were sitting there thinking, oh man, what's he doing? Take that out. Okay, should be 3d6. Not because the d sublevel can hold 6, it's because there are only 6 electrons left to get to 26. So if I put the orbitals in, it doesn't ask you to do all this, it just asks you what the quantum numbers are, but this is how you figure it out. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This time I do have a number I'm going to. 17, 18, 19, 20. I'm going to 26, 21, 22, 23, 24, 25, 26. So the highest energy electron in iron would be that one. It'd be the second electron in that orbital. If I do the m values for these orbitals, remember for a d sublevel, m is equal to what? Excuse me, L is equal to what? So L equals 2. That's for a d sublevel. So that means these are negative 2, negative 1, 0, 1, and 2, from negative L to positive L. So for this electron, this one right there would be, N would be 3, L would be 2, M would be negative 2, and S would be positive, no, negative 1/2. Why would it be negative 1/2? It's because it's the second electron into that orbital. So there's your 4 quantum numbers right there. Okay, a d orbital, you could either draw this. Remember, D's are the double dumbbells, or dumbbell and a donut. And remember, if you wanted to see those, there's pictures of orbitals in the quantum number section of the website on the course outline. So you'd have to go to chemistry course, advanced chemistry course outline, then go to pictures of orbitals. The other d orbital looks like this. It's a dumbbell and a donut. So that brings us into the last couple questions. A picture of all the orbitals you'd expect to find in neon. So neon would be 1s2, 2s2, 2p6. The orbitals themselves, all the s orbitals are spherical, and the p orbitals are dumbbell shaped. So there's 3 p orbitals. So here's what they look like. 1s is a sphere. Visualize that in 3 dimensions. I'm not a good enough artist to get that across probably. A 2s is a bigger sphere. And then the p's are the dumbbell shapes. And they are in 3 different directions, one on the x, one on the y, one on the z. Or if you wanted to all draw it all together, you could do that too. You'd have a 1s, you have a 2s, then you have a 2p. I think Shakespeare wrote about this when he was saying something about 2p or not 2p. Okay, and then we had the orbital diagram of vanadium. Okay, so vanadium is 23 electrons. Guess how I knew that? Oh, I looked at my periodic table. So I'd have 1s2. This is a configuration. It asked for the orbital diagram. I'm going to put the configuration down first. So this is called the electron configuration. Here are the orbitals. How many in the p sublevel? So you put the electrons in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, oops, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. All right, now the question says, that's the orbital diagram, so that's the first part of that question right there. Then it says how many electrons have an m sub L value of 0. So how many electrons are in the 0 values? Well, remember the L values. I'm going to put the L values in first. So the L value is 0. For S is all 0. For P's it's 1. For S is 0. For P's it's 1. For S it's 0. For D's it's 2. If L equals 0, M equals 0. If L equals 0, M equals 0. If L equals 1, M equals -1, 0, and 1. For L equals 0, M equals 0. For L equals 1, -1, 0, and 1. For L equals 0, M equals 0. For L equals 2, -2, -1, 0, 1, and 2. So how many of these electrons are in the M equals 0 orbital? So there'll be 2 here, 2 here, 2 here, 2 here, 2 here, 2 here, and only 1 there. So I think we're looking at 13. And that was the last question. So remember, I'll be online Sunday night at 7. Unless my wife, if something comes up, my wife says, "Oh, you're doing this on Sunday night," in which case I'll leave a note on the meeting words. So count on Sunday night at 7, unless you hear differently, and I'll check answers between now and then on the meeting words site. And that's it.